So in this video, I want to look at integrating products of powers of cotan with powers of cosecant. And the way that we approach integrals like this is exactly the same way that we approach integrals of powers of tan multiplied by powers of secant. And what we do is, rather than using the expressions secant squared x equals tan squared x plus 1 and tan squared x equals secant squared x minus 1, rather than using those identities, we use these two identities here, which will allow us to express a cosecant squared in terms of cotan squared and cotan squared in terms of cosecant squared. All right. Well, as with products of powers of secant with powers of cotan, when we're looking at an integral like this, the first thing that we should try to do is think about either breaking off a cosecant squared x or a cosecant x cotan x. Well, if we wanted to break off a cosecant squared x, that would work well if we were to try to then let u equal cotan x. But if we're going to do that, after we've broken off our cosecant squared x, we would need to be able to write everything else in terms of cotan without introducing square roots. So if we were to break off a cosecant squared x here, we'd be left with cosecant cubed x. And we wouldn't be able to write cosecant cubed x in terms of cotan without introducing square roots, because we're going to have, well, cosecant squared x we can certainly write in terms of cotan squared x, but we'll also have a leftover cosecant x, which will involve taking a square root. And we don't like, in general, integrating square roots that involve sums and differences if we can at all help it. Okay, so breaking off cosecant squared x doesn't seem like it will work, so next thing that we might try is to break off a cosecant x cotan x. So let's see what happens if we do that. Okay, so this is then equal to, so we're going to break off a cosecant x cotan x, so we're going to have cotan squared x times cosecant to the fourth x times cosecant x cotan x dx. And the reason that this seems like a good idea is because this will equal, well, I guess the negative in this case of du if u is equal to cosecant x. All right, because the derivative of cosecant x is minus cosecant x cotan x. All right, so if we want to do this and have this equal to our du, we'll need to be able to write everything else here, everything else that remains in terms of cosecant x. All right, well, cosecant to the fourth x is certainly written in terms of cosecant x, but we would need to be able to write this cotan squared x in terms of cosecant x. Can we do that? Well, yes, because cotan squared x is equal to cosecant squared x minus 1. Okay, so our next line, this is now equal to integral, so rewriting that cotan squared x in terms of cosecant squared x, we'll have cosecant squared x minus 1 times cosecant to the fourth x, and then we'll have our leftover cosecant x cotan x dx. As we said, we've written everything else in terms of cosecant x. We're in a good position to let u equal cosecant x, because then du is equal to minus cosecant x cotan x dx, meaning then that minus du is what we see here, cosecant x, cotan x, dx. All right, so we can replace this here then by minus du, and here we have a u, and here we have a u as well. Okay, so now we can write everything in terms of u. That's good. So let's see. So what we have, this is now equal to the integral of, well, cosecant x is u, as we said, so this is u squared minus 1 times cosecant to the fourth x is now u to the fourth, and cosecant x cotan x dx, that is minus du. So put my du here, and I'm going to put my negative out in front. Now this is equal to the integral. I'll just leave the negative there. Write this as the sum of powers of u, and we are in very good shape now to integrate this. So the remainder is easy. So we have minus 1/7 u to the 7th minus 1/5 u to the 5th, all plus c. And now this is equal to, last line, equal to, let's just distribute that negative through and replace u by what it is. In this case, u is equal to cosecant x. So this is equal to, maybe I'll write the plus 1/5 here first, distributing the negative through, cosecant to the 5th x minus 1/7 cosecant to the 7th x plus c, and with that we are done. So just to recall, in general, when we're dealing with an integral like this, which is a product of powers of cotan and cosecant, we should approach it just as we would if we had a product of a power of tan with a power of secant, using these identities here for cotan and cosecant rather than the corresponding ones for secant and tan. All right, in general, first thing you do is try to break off either a cosecant squared x and write everything else in terms of cotan, which you'll be able to do without introducing square roots if your remaining power of cosecant is in fact even. But if, as in this case, the remaining power of cosecant is odd when you break off a cosecant squared x, in this case if we broke off a cosecant squared x, we'd have cosecant cubed x. Well, in that case, try to break off a cosecant x times a cotan x. And then write everything else in terms of cosecant and let u equal cosecant x. That's what we did in this case here. Sometimes, though, both of these strategies won't work, and that is going to be the case in the next example. So our next example is the integral of cotan squared x times cosecant x dx. And, well, as before, we approach it just as we would approach the product of a power of cotan with a power of cosecant x, possibly, in fact very likely, using these identities here. Okay, so first thing that we would try to do always is break off either a cosecant squared x or a cosecant x cotan x. Well, we certainly can't break off a cosecant squared x immediately, so that's not going to work. So the other option might be to break off a cosecant x cotan x. If we were to do that, though, we would only be left with cotan x itself, which we would need to write in terms of cosecant x. We could write cotan x by itself as the square root of cosecant squared x minus 1, but if we do that, we're introducing square roots, which So in general, we don't want to introduce square roots of a difference or square roots of a sum. Okay, so we need to do something else. And, well, as with the secant and tan situation, what we do is we try to introduce some more cosecant x. So we want to see cosecant x show up a little more so that we might be able to try something else. Well, we can do that by rewriting cotan squared x in terms of cosecant squared x using this identity here. So that's our first step. So this is equal to the integral of cosecant squared x minus 1 all times cosecant x dx. All right, and simplifying this a bit, we'll have the integral of cosecant cubed x minus the integral of cosecant x dx. Okay, so now we have two integrals to deal with. This first one here, the integral of cosecant x dx, that's one that we should have memorized. Remember, whenever you see a trig function standing alone, like sine, cosine, tan, secant, cotan, or cosecant x, you should know the integral automatically, and we do know this one, so no problem there. But how are we going to deal with cosecant cubed x dx? Well, this is an odd power of cosecant x, and we have to deal with it in a similar way that we would deal with an odd power of secant x. And the way to deal with that is, in fact, by parts. So if you see an odd power of secant alone or an odd power of cosecant alone, the way to go about that is using by parts. So if you look in your notes, for example, at our section on by parts, the last example that we did was we integrated secant cubed x dx, and we could integrate this in exactly the same way. In fact, we could go off to the side and integrate cosecant cubed x dx using exactly the same method that we used to integrate secant cubed x and then put our answer in here. In this case, it's actually not necessary. We're just going to start integrating this by parts, not off to the side, but and we'll see how that's going to work. Okay, so what are we going to do? Well, if we're going to integrate this by parts, we're going to need to have a u and a dv, and for that, it's natural for us to let our dv equal cosecant squared x dx. So let's write another line here. So what do we have? This is equal to, so I'm going to just write this as cosecant x times cosecant squared x dx. This is exactly how we started our integral of secant cubed x by parts. And then let's just evaluate this second integral here. You remember that this is equal to the log absolute value of cosecant x minus cotan x. And we'll leave off our constant for now until we're done integrating. All right, remember, if you were integrating secant x here, the integral would be the log of secant x plus tan x. It's almost the same with cosecant replacing secant, cotan replacing tan, but we also have a negative sign here, so something that we have to remember. Okay, so as we said, we're now going to try to integrate this first integral by parts. Okay, so let's see. So we're going to try letting u equal cosecant x, and if we do that, dv is everything left over, cosecant squared x dx. Well, it doesn't matter what we let u equal, we could always find du, and it would be minus cosecant x cotan x dx And if we let dv be cosecant squared x dx, that's a good dv because we can figure out what v is from this. And what's that? Well, it's minus cotan x. Derivative of cotan x is minus cosecant squared x. So the derivative of minus cotan x is cosecant squared x. All right. So that's what we have. Now, this, our integral, is equal to, so it's equal to uv, which is equal to minus cosecant x cotan x minus the integral of v du. Notice that we have two negatives here, our v and our du, so that just gives us a positive, and v is cotan x, and cotan x, and then du is cosecant x cotan x. That gives me two cotan x's, so I've got cotan squared x and cosecant x dx. And then I'm just going to rewrite our last line from up above, which is log absolute value cosecant x minus cotan x. All right. Well, remember, when you're integrating by parts, you should always look for your original integral to appear. And what do we have here? Our integral here that we're looking at is cotan squared x times cosecant x. Cotan squared x times cosecant x. Well, there it is. That is, in fact, just exactly our original integral. So let's call our original integral here I. I better write this in yellow so that you can see it a little better. All right, so write it in blue. Okay, so let's let I be our original integral. I hope you can see that. Then, if we go down here, we see that we have I reappearing again. Okay, so what do we have then? We have, let's just write a new line here. So we have, just going to write my I all over again, if you don't mind. So what we have at this point is that our original integral, I, is equal to minus cosecant x cotan x minus I minus the log of the absolute value of cosecant x minus cotan x. And that means that 2I is equal to minus cosecant x cotan x minus the log of the absolute value of cosecant x minus cotan x. Finally, that gives us that I is equal to, divided by 2, minus 1/2 cosecant x cotan x minus 1/2 times the log of cosecant x minus cotan x, and we found all antiderivatives at this point, so let's just add a plus c, and at this point we are done. All right, so finally, as an exercise, why don't you try to do the following. So let's make it red because it's an exercise. So as a final exercise, why don't you try to integrate the corresponding integral with tan and secant. So tan squared x times secant x dx.